so today we want to focus on functions. All right, so let's just start quickly with what we call a relation diagram. Let's quickly take a look at a relation diagram. So it kind of relates, or it kind of gives a relationship between x and y values, right? So a function kind of gives us that relationship between x and y values. Let's say we have a few values here, 1, 2, 3, and 4, right? If we have those 4 values and we're mapping them by a function x plus 1, then in order for us to map 0 to its corresponding value, we just add in 1 to it, right? 0 plus 1 is 1. 1 is called the image of 1 is called the image of 0, right? And then sometimes they like to access to the ordered pair. The ordered pair is 0, that's the x value, and the corresponding y value. Okay? Similarly, 1 will be mapped to 2, 2 will be mapped to 3, 3 to 4, 4 to 5. Right? What type of mapping we have here? Right? This is called a 1-to-1 mapping. Right? The ordered pair is 0, 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, right? All those are examples of ordered pairs. All right. A few definitions that we need to learn about. Let's start with domain. Anybody remember what is domain? Set of x values. So in this case, our domain is 0, 1, 2, 3, 4. Definition. The domain is basically this consists of all the x values, right? Right, the codomain. This case is 1, 2, 3, 4, 5. Right? What's the codomain? Right? Codomain is the set of elements. Set of elements in which all the images are contained. And last one, I'll put this one a different color because it's the one that we tend to mix up. What's the range? In this case, the range is the same. In this case, the range is the same, and it consists of all the images. Right? All the images. I want to explain the difference between range and codomain, right? Right? So codomain is like where all the images come from. Okay? In this example, we can't differentiate between them because the codomain and the range is the same. You'll see that? But I'm going to show you an example where the codomain and the range is not the same. Okay? And then you'll understand what is the range and what is the codomain. Suppose that the function we use in f of x is x squared. Right? What will 0 be mapped to? 0 will be mapped to 0, right? What will 1 be mapped to? 1. Well, 2 will be mapped to. Right. So let's see if we can find the domain. Let's see if we can find the codomain. And let's see if we can find the range. I'll let try it on your own first. And let's see if we can figure out the difference between each one. Right? So what do you all think the domain is here? 0, 1, 2. The domain is 0, 1, 2. Nice. All the x values, right? What do you think is codomain? The codomain is where you get the images from. So all the values. The values don't have to be an image to be the codomain. Okay? But for the range, the values have to be an image. So what's the range?
0, 1, 4.
0, 1, 4. Okay? So here's an example of where the codomain and the range is not the same. The range must only have the images in them, right? All right, so that's just some definitions, right? Next, let's quickly take a look at the types of mappings. Let's see if we can name the types of mappings, right? So first one, if you look at the first one, there's one value in the domain going to two values in the range. You all see that? So that's one to many. So the first one is one to many. So once you have one value in the domain with more than one mapping in the codomain, that is your one to many. Second one is what? Right? Because you have many x values going to one y value. So this one here is many to one. And the last one is all over the place. The last one you have 1x to 2y and 1y back to 2x and so on. You'll see that? So that's a mixture, right? So that's many to many. All right, so the first one is 1x value to many y values. The second is 2x value to 1y value. Right? And the third, well, both of them. One to many, and you will see many going to one. Well, sorry, one is here. Okay, so those are the four types of mapping: one to many, many to one, many to many, and the one I showed you earlier, which was one to one, right? Nice. Let's continue. Copy down the mappings. All right, next, a few definitions. Right, sorry, it's a little long, but I wanted to point out this last part because there's a multiple choice that you have to know this little piece here, right? So a function is a relation in which each element is mapped to exactly one. Not necessarily different, but can only be mapped to one, right? Output element with no, right? With no input element being left out. So you can't have a one-to-one mapping like this. You can't have a one-to-one mapping like this and one of the input values are left out. Right? This here, this example is not a function. Right. Which of the four mappings are functions?
One to one.
One to one for sure. Which of the mappings are one to one for sure? Read the definition again. Each input element is mapped to exactly one. Correct. Many to one. Right? Because they have many x values mapping to one y value, right? So the input only has one output. Although they are the same, right? Nothing wrong if they are the same. To determine if the relation is a function, right? To determine if it's a function, right? We right, use the vertical line test. If it's a function, right? Right, of course, in case you all don't know it, your vertical line test is where you draw a function and draw a vertical line. Right? If the line cuts once, then it is a function, right? Right, I'll just give you two quick examples here. If you were to draw this and do the vertical line test, it don't matter where you draw it, it'll only cut once, right? So this appears to be a function, right? And two, if I give you one that looks like this, and you do a vertical line test, right? This is not a function, right? Because it has two y values, one here and one here. It has two y values, right? One there and one underneath. So it's not a function, right? Next thing you want to look at, you want to look at three things, right? We would like to take a look at injective, surjective, and bijective. Right? What does injective mean? Real short. Injective simply means one-to-one. Right? It simply means one-to-one, right? Every element in the domain has a unique image. So injective means that the function is one-to-one. How do we show one-to-one? Right? So to show injective, we have two techniques. We have technique A, horizontal line test. And B, if f of A is equal to f of B, then we should be able to get A and B being equal. All right, so I'm going to show you how to show injective. We have two techniques, right? The horizontal line test, which is the easiest, provided you can sketch it. And then we have the mathematical way. If f of A and f of B equal, then A and B should be equal. All that's saying is if you put A and B into it, you should get them being equal. It's a function. All right, good. So here's what we have. We have the same function, but a change of the what? What a change of there. Look at it closely. The domain, nice. Good job, Brianna. So I changed the domain. Right. I have a little question here. How do I sketch that? We did that last week. What does plus one do? Ship it up. So the graph will look like this. How do we determine if it's injective? Well, because we want to so we do the horizontal line test. And if it cuts more than once, if it cuts the function more than once, then what? Right? It fails the horizontal line test. Therefore, not injective. You'll see that? So what that's saying there is that it have two x values giving you one y value. They have two x values giving you one y value. Therefore, it is not injective. All right, that is the graphical way to do it. Right? Let's say we can't sketch the graph, then we have to go to the mathematical way, right? Sketch the graph, copy it down. The mathematical way is this now. If f of A equals to f of B, we have to show that A equals to B. So we have to do some kind of maths and show that A equals to B. Alright, so watch this here. Watch it first. Watch it first. F of A is B squared plus 1. F of B is B squared plus 1. Carry across the 1, so it'll cancel. And you'll get A squared, B squared. What's it do now?
Square root things.
Square or square root?
Square root.
Right, so when you square root, carry across this, you would get square root of B squared. What others? Anybody? Online? What is square root of B squared?
Plus or minus.
Huh?
Plus or minus.
Plus and minus. Plus and minus B. Okay? So if you look there, because A is equal to plus B and A is equal to minus B, then the rule doesn't hold. Not injective. Right? So it's not injective. But if we got A equal to B, then it is injective, right? So I want you now, based on what you learned in example 1, try part B, but I want you to do it both methods, horizontal and. All right, let's see what we got. So remember, we only want the positive real part. So the graph looks like that. If you do the horizontal line test, it will only cut once. Right? No matter where you put the function, it will only cut once. So therefore, injective. If f of a is equal to f of b, right? Then you will get a squared plus 1 is b squared plus 1. A squared is b squared. A is plus and minus b. But remember, negative b is not in the, right? Negative b is not in the range. So therefore, a is equal to b and f of x is injective. All right. So there are times when you can't really use the graph. You can't sketch, so you will have to do this test. There are other times when it's much easier. All right, let's go again. I showed you, what did I just show you? Injective. I'm going to show you surjective one time. Right, surjective in short, I'll give you the short version first. The codomain equal to the range. Once we could show the codomain equal to the range, then it's surjective. Right, this also states that, right, the set of images of the domain all right. So when the set of images equal to the codomain, what we have is a surjective function. Right. By looking at it, A is surjective or not? Not surjective. Why? Right? Because these values are not images. It must have an image, right? Every value in the codomain must be an image. Okay? So those two are not images. If I were to try to find, and I will show you this test later on, if I were to try to find an x value for 4, it doesn't exist. If I were to find an x value for 6, it doesn't exist. So by doing that, I could show that the function is not surjective. Right? So notice x values of 4 and 6 do not exist. And what about b? Surjective or not?
Yeah.
Surjective. All right. And last definition before we try a past paper, bijective. Right? Bijective is both injective and surjective. Right? That's the last definition. Let's see if we can apply all of this together. All right, take a little read. It combines last week and this week, right? Let's see if we can do that. So let's see. X minus 2. What will that do?
Shift it downwards to.
Right. It will shift the entire thing downwards 2. So will the x value change? No. The y value, the x value stays the same, but the y value will drop by 2. So the answer will be 1, 1. Okay? 1, 1. And Sarah? Right, Sarah? So what happened in the end? Plus 3 means what? Shifting where? To the left, how much? 3, right? And shifting to the left 3. So will the y value change?
No.
And the x value becomes what?
-2.
Nice. Easy. Next one, 1 to 1. How we showing 2x, 3x minus 2 is 1 to 1. But the easiest technique is, so you have to do the horizontal line test or the mathematical test, right? So you can draw it if you want, or you can just do the mathematical test, anyone you want. Right, so I am going to do the mathematical method. F of x is equal to 3x minus 2. If f of a is equal to f of b, we have 3a minus 2, 3b minus 2. The 2's will cancel off. 3a is equal to 3b, divide by 3, and you'll get a equal to b. Therefore, 1 to 1. And then the last part is where we have to go back to Form 5 maths. Find f of x plus 3 and make it equal to f of x minus 3. Right? So find f of x plus 3, that's Form 5 maths, right? So all we're going to do is plug in x plus 3 in there. So it's 3 by x plus 3 minus 2. And then we have to find f of that. So you're going to get f of 3x plus 9 minus 2, that's plus 7, is equal to f of x minus 3. And do it again, 3 into 3x plus 7 minus 2 is equal to 3 into x minus 3 minus 2. So this is 9x plus 21 minus 2 is equal to 3x minus 9 minus 2. So it's 9x minus 3x is equal to minus 11. 21 minus 2 is 19, so that's minus 9. 6x is equal to minus 30. X is minus 5. So it's kind of just building on what you would have done in Form 5. I want you to determine if 1 to 1. Again, you have to remember the last week group. How are we going to ensure that 1 to 1? Let's see if we can do the graphical method. So look back at what we did last week and see if we can do the graphical method there. How are we sketching that? How are we sketching that? So it's going one upwards and 1 to the right. Before that's not just how it's stretched, right? But you can't really show a stretch on a graph, right? You can only show a stretch if you compare it to something else. What you all think, 1 to 1? So if I were to draw a line anywhere, a horizontal line, could it only touch 1 once? So therefore it is 1 to 1, right?